And with Descartes' rule of signs, the way we're going to do this is one of those things that if you had a problem where you had 80 different solutions that you had to check to find the answers for, this would be one of those things that you would kind of use to help you speed this thing up. For most of the problems that we're going to do, it's not really going to be that helpful because sometimes it does and sometimes it doesn't, and it's just kind of a trade-off of exactly how it goes. But basically, here's what it is. There's two parts to it. Basically, they say, here's what you've got for this one. It's the possible number of positive solutions of f of x is the amount of plus or minus sign changes. In f of x. Now, if we stop there, it'd be really easy because if you do this, and we'll show you one in a second, where you go through and you count how many times the sign changes. If there's 5, there's 5, there's 4, you count how many you have. But here's the thing. The way this is set up, because you always have that possibility that you may have complex solutions which occur in pairs, or maybe that you've got a radical solution, or imaginary, you got all those different possibilities of answers that you could have that it could occur in pairs. So it could be that when you get an answer, there may be that there's imaginary solutions involved. So they say, all right, well, it's the number of plus or minus sign changes that you have in f of x, or an amount less that by an even number. Now here's basically what that means. The solutions occur in even numbered clusters. This is kind of the way I always think about it. Or occurs in odd numbered clusters. And basically, here's what you got to. This is the visual I get when I'm trying to think about this one. Pretend like you got a bunch of grapes. You count, and the grapes are the sign changes. Let's say you've got 10 grapes on there. You've got 10 sign changes. The rule is that if you're going to pick one grape, you have to pick 2 grapes. You got to pick a pair at a time on these. So if you start with 10 grapes and you pick 2 of them off, you could have 8. Or you could have 6, or you could have 4, or you could have 2, or you could just eat the whole thing and not have any, right? So the way they say it is, all right, if you start with 10, you could have 10 answers, or you may have 2 complex answers because of the whole conjugate thing, which means you could have 8, or you could have 6, or you could have 4, or you could have 2, or you could have none. And all that Descartes' rule says is that it kind of narrows the choices down, so that if you know how many sign changes you have, you know for how many real number solutions to look for. Which again, if you've only got to check 6 or 8 questions, it's not a big deal. If you're checking 60 or 80, kind of a big deal if you're looking at the overall big, huge part of this one. Okay, so that's kind of the first thing. The second thing, which is very, very similar. So it's the number of negative solutions. Of f of x is the amount of plus or minus sign changes in f of negative x. And same rule goes that they occur in even or odd pairs. So if you had 9 sign changes, which you won't ever have any that's got 9. Same thing. If you've got 9 grapes on there, they tell you can only pull off 2 at a time. So you could have 9, you could have 7, you could have 5, you could have 3, or you could have 1. And if you start with an odd number, you'll never get to 0 because you can only take off 2 at a time. Okay, so let's give you some examples here. We'll throw a couple at you. So they'll tell you to use Descartes' rule of signs to determine the possible number of positive and negative row zeros. Because we'll do 2 or 3 questions, so that'll be our direction that we're looking at. Now, and if there's any one question that helps you out, this is the problem, that if you get one like this is the kind of question that you want to kind of look at, because this is one that you get an answer that kind of jumps off the page at you. And then we'll come back in a second and change it where you've got some that's different numbers. So here's what first thing you have to do. So basically there's the positive would basically be part A, and the negative is going to be part B. So there should be 2 parts. You got to go back and fill in the blanks on this one. So for the A part, you don't do anything different to the f of x. And here's one where you've got to kind of, it's kind of like the match question. You know, don't make it harder than what it is. How many times do the signs change there? If they're all positive? None, right? So there are 0 sign changes. So if there's no sign changes, that means that there are no positive solutions. Now, and that's why this is the one question that if you get a problem like this would help you out. Because if you get one like this, where if you look at it real quick, and this is kind of those eyeball tests, if you look at it and you go, well, all the signs are the same on this one, that means that there's no positive solutions you can plug in on this thing that's going to work, which means there's no need to check in the positives. When you got that list of 6 or 8 or 12 numbers, don't check the positive, because none of them are going to work. So right off the bat, you can cut down how many you've got to check on your synthetic division, cut it in half, because none of the positives are going to work. Then, you know, if you want to go a step farther, for the B part, well, now we're going to do it where we're doing f of negative x. Okay, so we're going to do negative x to the third plus 2 times negative x squared plus 5 times negative x plus 4. Okay, now, and if you think about when you're plugging in negatives, anytime, basically here's what's going to happen. If you do a negative to the third power, that's going to make that answer a negative. If you do a negative squared, that's going to make it a positive. Well, you got a positive times a positive, so that's going to be 2x squared. Positive times negative makes that a negative 5x. And then the 4 doesn't have an x with it, so it's not going to change. So we got negative, positive, negative, positive. Now, here's one of those, again, don't get in a hurry on these, because this is one of those, I remember somebody showed me one time a paragraph, and it was real simple. They said, find the amount of f's in the paragraph. I go through or read through real quick. I was like, there's 3. They were like, no, there's 6. And it's one of those things where sometimes your eyes, you start looking for something and it's just not there, or it's there but you just don't really notice it. Kind of one of those things that they can give you you can take the words in a sentence, make the first and last letters the same, but change every other letter in the middle of the word, but you can figure it out by just looking at it and kind of playing a word association. This is one of those things where sometimes people look at this and they've got the answer off the bat, and then you slow down and take your time, and it's like, oh, okay, now I see, kind of going through in a bit of a two-hurry. So here's what I did. This is the easiest way I could always do this. Go from here to here. Did that sign change? Went from negative to positive, so there's one sign change. Go from here to here. It was positive, it's negative. That changed, right? We went from negative back to positive. So there's actually 3 sign changes on this one. So 3 is the max. And here's where that whole even odd thing comes in. You've got 3 grapes on there. They tell you can take off 2 at a time. So if you take 2 off, you're also left with 1. So you could have 3 or you could have 1 negative solution. So that would be a 2-part question where part A, they're going to ask you how many positive. In this case, there's no positive solutions at all. And the negatives, you're going to have 3 or you're going to have 1. So you know you're going to have at least 1 negative solution. You might have 3, and that's one of those that you don't know until you just start going through and doing synthetic division to find out what it's going to be. Now, and honestly, and this is one of those questions where there's going to be one question, I think there's 2 or 3 in the homework, where it just says use Descartes rule of signs. They give you an option that some of the problems they'll tell you to find all the solutions, and they say you can use synthetic division, you can do Descartes rule of signs, you can do all those things. You don't have to do Descartes rule of signs if it doesn't say so, because unless it's a problem like this where the very first part, too far, is all positive, honestly, it's probably more of a waste of time to check it than it is just to go back through and do synthetic division. All right, let's give you one more, though. So let's go 5x to the third minus 3x squared plus 3x minus 1. Okay. And again, big thing on these, don't get in too big a hurry, because sometimes people jump and they go, oh, there's 1 or there's 2. Just take your time and go one number to the next. So there's 1. There's 2. There's 3. So again, there's 3, but everything occurs in groups, clusters, if you want to think about it that way. So there's either 3 or 1 positive solutions. Okay, for part B, you've got to check negative x. Okay, do a negative to the third power, that makes that a negative, so it's going to be a negative 5x to the third. A negative squared makes that a positive, but then you've got a negative times a positive, so that's still going to be a negative. Positive times negative is a negative, and then a minus 1. Okay, now again, this is sometimes where if you do these real quick, just do a quick glance of it. This is another one where when you get to this part of it, there's no sign changes. So there's 0 negative solutions because none of the signs change at all. So again, another one of those where if you just check it real quick, you're not going to check the negatives because nothing's going to make that work out from the negative point of view. So everything has to be a positive. And you're either going to get 3 real number answers or you're going to get 1 real number answer and 2 that could be imaginary answers. And that part you don't know until you start going through and doing synthetic division and checking through everything. Okay, so one last problem where it's everything all together. Okay, so they'll tell you find all the zeros, and this is one where they'll tell you you can use the rational root theorem or the rational zero theorem, Descartes rule of signs, use your graphing and your turning and the amount of turn, all that stuff. It says do everything, anything you need to help you get the answer, go for it. But the big thing is for this one though is that you're always going to have to start off basically the same way every time. Okay, so very first thing is you've got to figure out what the possible solutions are. So that's going to be the factors of 10. And the good thing about this one is that first term is 1, so that's going to make this one a little bit easier because basically it's just the factors of 10. Okay, so to get 10, it's 1 times 10, or it's 2 times 5. And again, for this one, it's over 1, but again, dividing it by 1 doesn't change anything, so these are all the possible solutions. So these are the ones that we're going to have to check by synthetic division. Okay, now, if you want, now here's where it's all up to you and whether or not you want to do this or not. If you go back and check this one, if you check the signs, this was positive, negative, negative, positive. Well, here's one sign change. Didn't change here to here, changed negative back to positive, so there's 2. So positive solutions, you're going to have 2, or you're going to have none. So if you find one positive that works, you know you've got at least one more positive that's going to go with it. Has to be. That's just the way it's going to go. Here, and again, here's something else. They wait till you get to 2, 6, I think it is, and again, I don't know why they do this. I think we mentioned this last time. Whatever your highest power is, you're going to have that many solutions. So you got to have 3 solutions. And if you want to check the negatives, now here's a shortcut on the negatives. Anything that's got an odd power, you're going to change the signs of those numbers. Because if you plug in negative x here, you're going to do a negative times a negative times a negative, which will make it a negative. And you'll do a negative times whatever this number is. So basically, these 2 numbers are going to change. Anything even, when you square it, it stays the same. So if you're doing the negative solutions, this one would be a negative. That's going to be a negative. That's going to be a negative. The last one's going to be a positive. So if you did f of negative x, your signs would be this. So there's only one sign change here, which means there's only one negative solution. So when you're doing synthetic division, once you get one negative answer, you don't have to check any of the other ones because there's not going to be anything else. There's only one that's going to work. All right, so here we go. Which one do y'all want to try first? Again, I'd say start small. Positive or negative 1? Positive 1. Okay. So it's just guess and check. So we're going to take 1 and do some synthetic division. So our numbers were 1, negative 4, negative 7, positive 10. That one. 1 times 1 is 1. Negative 4 plus 1 is negative 3. Negative 3. Oh. Negative 10. That's 10 is 0. Okay. So 1 did work. So that's one positive solution. Now, and again, if you go back, if you didn't do Descartes rule of signs, wouldn't be that big a deal. But in this case, we did. So now that we've got 1, we know there's one more positive solution that we're going to get. And you have 2 options from here. You can either keep doing synthetic division and find the second one, or here's what they really would like for you to do. We started off with x to the 3rd, right? If you had this rewritten now and had it doing synthetic division, they said tell me what the answer is. This would be x squared minus 3x minus 10. And here's what I would say to do. Can you factor that? And if you look at it and you go, well, I'm not so sure if I can. All right, if you're not sure if you can, do synthetic division on this problem now. You could basically restart it from here. But hopefully on this one you'll kind of check and see that one would factor. So to get 3, it's going to have to be 5 and 2. And since that number is negative, the bigger number's got to be negative, which means that number would have to be positive. So this one will subtract 2 to get negative 2. This one will add 5 to get positive 5. And don't forget the first one, which was x equals 1. Okay, so there's your 3 answers we were looking for. And the way the problems are set up is that once you get the first answer, I would say once you get to here and you've got one that actually works, take this problem and rewrite it so it's x squared minus 3x minus 10, or if it's, if you started with x to the 4th, it would be x to the 3rd minus whatever. And the question always gets here is, could this thing factor? If you can, go ahead and factor it off. Now, if you're not able to, then start back with this problem and start it over. You've already tried 1. Well, then I'd say the next one, go back and either try negative 1 or go back to positive 2. If you've done positive 2 on this one, 1 times 2 is 2, negative 3, it's negative 1, 2 times 1 was negative 2, that would have been negative 12. You realize that one didn't work, and then if you had tried negative 2, this would have made this a negative 2, that would have made that a negative 5, negative times negative would have made that a positive 10, that would have been 0, and then you would have had your next answer. So then that would have been your second one. And if you'd gone synthetic division on this problem, now you've got x minus 5 equals 0, well, then you're right back here. So once you get one answer, basically start the problem over, and now check this one. See if you can factor it. If you're not able to factor it, then just keep going through and doing synthetic division. And sometimes when you do that, this one didn't work out this way. But sometimes when you're doing a problem like that, you'll get here, and you may have an answer that says you've got x squared minus x minus 2. And you may go, well, okay, well now I've gotten rid of all the factors of 5 and 10. Let's say you found 5 first. Well, if you found this answer first, that's going to change this last number now, so it's 2. So now you don't have to check 5. You don't have to check 10. Now you're down to checking 1 and 2 from this problem, and you've got fewer numbers to check. Sometimes it happens, sometimes it doesn't, but anyway, that's what they want you to try to do, is that once you get one answer, see if that'll factor out, or at least give you a smaller number at the end, that then you can start doing synthetic division, maybe get rid of a few options that hopefully make the problem go a little bit faster.